So on this example, we are given this graph of a rational function, and we want to find the domain and range, the intercepts, horizontal asymptotes, vertical asymptotes, asymptotes. So starting with the domain and range, for domain, we're going to assume that the ends of these graphs continue on. So we're pretending like they have arrows and the lines continue on. And the dashed lines that you see on the screen are the asymptotes. And they indicate where the graph is approaching that line but not reaching the line. And so this function, this graph, will have a break at the asymptote of x equals -3 and another break at x equals 3. So I can kind of see, and I like to use a ruler if I'm not sure about it. And I'm going to hold my ruler vertically. And the reason why I hold it vertically is because it points to your x-axis. So if I go from left to right, I can see that all of these points on the x-axis are covered until we get to that vertical asymptote. What I mean by covered is that I'm touching the graph, and if I'm touching the graph, I'm also having an x value at that place on the x-axis. So it's covered all the way except for those two asymptotes. So I know that my domain is going to be all real numbers except for those two asymptotes. So you can write that in interval notation, or you can write it in set builder notation. If you write it in interval notation, that would be -infinity to -3, union with -3 to 3, union with 3 to infinity. If you write it in set builder notation, we're talking about domain. So we're going to do a set of x's, and we want to exclude only 3 and -3. So it's all real numbers except for 3 and -3. For the range, we have this one horizontal asymptote, which is occurring at x equals -3. And we'll notice here that there's a gap in the y values. You could also use the ruler again and hold it horizontally. Horizontally because you're pointing at the y scale now, and range is the y values. So you can see that down here, my ruler is touching the graph, so that means that this graph has all of these y values below the horizontal asymptote. However, when we go above the horizontal asymptote, there's a little section right there that I've highlighted where I'm not touching the graph with the top part of my ruler. So for this group of y values, we have to exclude them from the range because we have no ordered pairs on this graph with those y values. And then from here on up, our ruler is touching the graph, and we have parts of our range included. So if we were to write our range, remember this is the domain, these first two, the range in interval notation would be -infinity to -3, and then -2 to infinity. Now you'll notice that I have put a parenthesis on the -3. That's where the asymptote is. My graph never reaches that asymptote. It keeps getting closer and closer. However, I've put a bracket on the -2, and you can see, looking at this particular point on the graph, this is the ordered pair, 0, -2, and it's on the graph, so we would include that -2. If you were to write this in set builder notation, we would use the curly braces and use y, since we're talking about y values with the range. Below the horizontal asymptote, the y values are less than -3. And then above that horizontal asymptote, those are y values that are greater than or equal to -2. So we want y values that are less than -3 or y values that are greater than -2. So we found the domain and range. Now we want to find the intercepts of this graph. So I'm going to get rid of all my markings so it's a little bit easier to see. And you can see that we do have some x-intercepts here and a y-intercept here. We already listed out that y-intercept as 0, -2. And the x-intercept is a little bit hard to read from this graph because we have all these extra tick marks. So I need to figure out what the value of a tick mark is before I can figure out what those x-intercepts are. So what I'm going to do is just look at one set of tick marks. Let's go from 0 to 1 here. And let's count how many spaces we have. We have 1 space, 2 space, 3 space, 4, then 5. So we have 5 spaces in between 0 and 1. So we can think of these as each fractions. This is 1 out of 5, which is 0.2. This is 2 out of 5, which is 0.4. 3 out of 5 would be 0.6. 4 out of 5 would be 0.4. And 5 out of 5 would give me 1. So that's how we need to think about those tick marks. So let's see if we can figure this out. We've got our x-intercept here. I'm going to erase that so we can see the tick mark. So we've got 1 tick mark, 2 tick marks below. So that's going to be a -2.4. And this one on the right-hand side will be 2 tick marks above. So that's going to be 2.4. So we have intercepts -2.40, 2.40, and 0, -2. So now we're going to look for horizontal asymptotes, vertical asymptotes, and oblique asymptotes. And we really had to already find them to understand what the domain and range were. So we located a horizontal asymptote at y equals -3. So that is part C. Y equals -3 is the horizontal asymptote. Vertical asymptotes, we had 2 of them at -3 and 3. And that's x equals 3, x equals -3. And for part E, asking about oblique asymptotes, an oblique asymptote would be a slanted line, and we don't have any slanted asymptotes here. So we have no oblique asymptote for this example.
Thank you for checking out my videos. Have a great day.